Hello good people, welcome back to my channel. We are continuing with our layout, right? And we in our last video we were talking about the dishwash area, and we designed the inlet sink, that is the pre-rinsing, then the runout table, the racks. Like I said, we are not going to deal with the racks because we did at length with the racks at storage area, dry storage area. And also the receiving table. The receiving table is more or less the same as the one that is found in the goods receiving area. The difference is the chute. Whereas in the goods receiving area, you just provide a small drainage for the water in the dishwash area. The chute is big, like diameter of 150 or 200, where you scoop all the leftovers in the plates down into the waste bin. We also dealt with the waste bin right around the goods receiving area, so we are not going to repeat that. You can as well refer to the previous drawings. I will put a link in this below in the description for the waste bin and the receiving table, and also the 4-tire rack. Right, so with that said and done, we will go straight to the servery area. And as you can see, in the servery area we have a hot cabinet, a low-level hot cabinet with two heated overshelves, what we call hot pass, and we have a bain-marie, a 5 container, 1, 2, 3, 4, a 4 container. This will be determined by the space available and also the requirements of the client, right? You can do a 4 container, 5 container, 6 container. You can do full GN containers or half GN containers, depending with the client. But today we are going to talk about the hot cabinet, or the hot cupboard if you want, and we will see how it goes. Like, here is the hot cabinet with sliding doors, with 2 sliding doors and a mid shelf. We have a mid shelf, and this panel is removable. You fix it with self-tapping screws, or if you want, bolt and nut. That depends with how you want your fabrication. But here it should be removable, because here is where you will fix your conductors, your electrical connections. All of them will be here. And in case you want to do your servicing and all that, this panel should be fixed. Unlike on the other side, right? On the other side, the panel can be fixed. You can tack weld it if you want. There is no point of putting self-tapping on this other side, because there will be nothing in there. Right now, there is the overshelf, the 2-tire overshelf with a hot pass. If you cannot access a hot pass, you can do the same thing that you will do to the undershelf and probably the mid shelf by putting an electrical heater to keep the cabinet heated, right? And the electrical parts, I'm not an electrician. They know better. They do conductors and thermostats and all that. They know better. Now, on the overshelf, as you can see, I have put a brass grommet, because this is not welded permanently to the top. We normally secure the overshelf on top of the hot cabinet with the help of bolts and nuts, and the grommet for the purposes of beauty and hide that base plate that is carrying this leg and the bolts and nuts. So that is why we normally do brass grommets. Right now, the if I may pull the drawing, Now I have changed transparency so that you may see, and you may also see the profile of the how it will be like, but you're going to see it as we do. And the sliding doors, they are sliding with the help of rollers on the top. So we are going to see how to do that. Let me see, sliding door, let me change. Where's the sliding door? Sliding door, I want to change the transparency of the sliding door. Anyway, you're going to see how the sliding doors work and how the channels are fixed in place, right? So that the doors might not, they might slide smoothly, and there is a very small U-channel we put in between the doors so that this front door might not swing to the front or inside, going towards the inside. So by the time we are done, you will have known how to fix sliding doors. They are normally hectic to fix. And again, as you can see, the profile of it is a double skin profile. The side panel is a double skin, you can see, right? And this other side, so that you may have room to put your electrical connections and all that. And for the purposes of cleaning, you can clean from behind here without any dirt getting stuck at the corners. It's just a smooth sweep. The same applies to the bottom shelf. That is why we don't have bottom rails for the door, because you don't want to have issues while cleaning. Now, if you decide to do one eating element on the undershelf, it is always recommended to punch holes on the mid shelf so that it may penetrate to the mid shelf, and all your plates and all whatever you are going to be storing there will be eaten. So one may ask, why an heated cupboard? This cupboard is heated. Remember, it is in the savory area. This is where you store your plates. From the dishwashing area, they have been stored here, and now you are ready to serve food, and you want to serve food which your customers, you want them to get food which is hot. Is it hot or warm? Yeah. So you don't want any complaints. You're serving people with cold food and all that. So you put your plates in the cabinet which is heated. Yeah, and if you don't have a plate warmer, it basically works like a plate warmer, only that it gives you more storage space, more warming space, if I may say. And also the overshelf helps in the bain-marie will be somewhere here. You are serving from the bain-marie, putting them on picking plates from the hot cupboard, serving the bain-marie and passing them through the hot pass, right, which also is heated. So at no point will this food get cold while at the savory area. So I think that is it. I don't think there is anything else that I should mention about this, or if in case of anything, we will mention as we continue with the design. So without much ado, let us get right into it, and we are going to start with the top. Alright, so here are the dimensions. The overall size is 1800 by 700. The overshelf is 300 by 1770. You just offset it in the inside with 15 millimeter on this side and 15 millimeter. The total height of the cabinet is 860, and the total height of the overshelf is 500. So let us go ahead and start the design with of the top, and we go to new file, part, click OK, top plane, new sketch. Like I said, most of these things you just use Weldments. Yeah? We don't worry, just bear with me. Let us finish the layout, then we will start with other functions of SolidWorks and other tutorials. But for now, let us continue with our sheet metal. Okay, so we'll start with a center rectangle. Size is 1800 by 700. Go to sheet metal, base flange, and the top has a thickness of 1.5 millimeter. Remember, you can do 201 or 304, grade 201 or 304 stainless steel. Click OK. There you are. Edge flange. This has edges in all sides which are equal and going in the same direction, and the size of the edge is 50 millimeter. That's the end condition. You keep it blind, 50 mil. Then from there you have your another edge flange, 15 millimeter going to the inside, all corners 15 mil. There is a difference, I forgot to mention, there is a difference where you decide to choose your edge flange and also where you want to keep your material. You can keep it outside, you can keep it inside, you can, you know, just be careful when you're doing that, so that your cutting size might not, you intended to have an 1800 by 700 equipment, and since you didn't check on that, you end up getting a different size. Okay, so I'm saving the top under my layout, and I'm going to create a new folder and call it, should I call it hot cupboard? Okay, then I open hot cupboard, part number 1, HC top. Right, now if we were to evaluate this and take the measurement from this edge to this edge, I think I should have broken the parts, did some dimension on every part alone, so that you may follow. This is 670 because of the 15 millimeter. Now 670, if I may pull this, as you can see, this is the back panel. There will be a small joint right here, and this will go all the way to the inside of the back panel. So let us do part number 2. File, new part, click OK. We go to the right plane, new sketch, center rectangle, snap it from the origin. The height is 710. Click OK. The width is 670. Let us do 668. 2 mm allowance, bent in allowance there. Go to sheet metal, base flange. The panels and the undershelf and all that can be 1.2 millimeter thick. That's okay. Now, just observe carefully how we will do, how the profile of the side panel looks like. It goes on the outside 100 millimeter. We want to have enough room for your conductors and all that, the electrical part. Click OK. Then we have an edge flange again here of 25 millimeter. 25 millimeter, not 125, but 20. You can even do 30. There is no arm. I don't know why I didn't show. Actually, this looks a little bit bigger than 30. Let us make it let us make that edge flange 50. 50 is ideal, right? Then we have an edge flange going to the inside, and that edge flange should be 25 millimeter. 25. What's going on? Yes. Then it goes again. This is also 25 millimeter. This acts as a stopper, or if you want, as the part that you're going to do punch holes for the self-tapping. Now we will have an edge flange round on the remaining parts. This side, this should be 10 millimeter or 15. Also, the size of these edge flanges are determined by your benting tool. If you have your benting machine can achieve a 10 millimeter, 8 millimeter, it's okay. This ideally is to give the panel some strength. If you want, you can have another one here, and finally here, and also to avoid what we call sharp edges, right? Edge flange here and another one here. Exit the edge flanges, and as you can see, our side panel is done. So go ahead and save it and call it part number 2, HC side. I always have this issue, side panel. Beautiful. Now, as is normal with me, once I have 2 parts, I tend to like starting my assembly right away. So we have opened new, do assembly. We start not with that, but with the top and the side panel. Top, side panel. Now do mate coincident relationship, and this part, the top part of the side panel, the top part of the top, bottom part of the top, then this side mates with this. That's okay. and the front part or the rear part to the front part. Yes, there we go. Exit the matting. Right, now we want to do our back panel. Our back panel, let us do the back panel. Go to file. Before we go to file, let us save this as our HOT cabinet with over shelf. What is the spelling of shelf? Is it LF or VE? You know, this language was brought to us, but we really appreciate it. Don't know how we would be communicating to the rest of the world. Now we are doing the back panel. So open new part as usual. Choose the right plane, and in this case it's the front plane. Center rectangle. Snap it from the origin, and the size is 670. Remember the 15 millimeter. We do 668, and the height is equal to that of the side panel, which is 710. Go to sheet metal base flange. This also is 1.2 millimeter thick, and do edge flange on these two sides. This should be end condition 50. You can do 50 is enough, don't do 100. Remember the side panel has a edge flange which is going to this side at 50 millimeter. That's good. Now another edge flange going on the inside 25, just like the side panel. Did we do 25 or 30? We will confirm that in a short while. Then finally, edge flange there, and this is definitely 25 millimeter, just like the other one. Now do edge flange again, this side, going on the inside, going to the inside, this side, this. Let us first give it a size of 15 mil, and also this. If you do a flat pattern of this, you will see how beautiful it will be looking, and with the notching and all that, and you have your CNC machine, you can cut it really well and do your benting, and you're going to have a very strong profile, right? Very safe actually to work with, because no sharp edge anywhere. Edge flange. The only problem will be when you are doing it manually, you don't have a CNC, you'll have a lot of notching and all that. But it is very important to avoid those edge flanges. Can we try to do a flat pattern? And we give it front view. See, it's not like it's a very hard thing to notch. It's not hard to notch. Okay, you know the drill. If you're using CNC, you export that in DXF, edit the cutting lines and the marking lines and all that, and feed the program to the CNC machine and do your cutting. This is part number 3, H. Let's see what's going on. 3HC back panel. go back to your assembly, insert component to insert is back panel. Now mating, just like the side panel, this part touches the bottom of the top, that's okay, and the back part of the back panel touches the edge, the 15mm edge of the top at the back, and you can do width if you want. If you don't want, you can pull this and go to top panel, grab the right plane and go to back panel and mate the right plane of the back panel, and there you are. Now you can see our profile is taking shape. No. Do we have an issue here? This should not clash. Those two, this part and this part, should not clash. But when you are doing assembly and the welding, I'm sure this will always mate really well. Now see the profile, how it is going from the inside going to the outside, then like this, then you provide a small edge flange here for the purposes of doing what, of creating some room for the what do you call it, the cover, the side cover, to cover the electrical part, right? No. Is there something that is not right here? I feel like it's right. Now remember, when you are joining or rather doing the welding, you don't want your welding to show here at the back. Now we need to reduce this slightly. This can be 666, 4mm, 2mm to the front, 2mm at the back. I wanted to see the size of this flange is 25, right? And also that one is 25. So there you go, you are good. Let's see. Yes, it has disappeared. You see, it was protruding from the back panel. But again, you don't want to give a huge gap, because you are expected to do a tack weld here at the top and at the bottom. Don't do any welding here. Okay, if you do any welding there, it will show up at the back side of your cabinet and it will look ugly. So tack weld here, tack weld here at the bottom. Actually, let us do the undershelf. The undershelf, new file, part, click OK, top plane, start new sketch, center rectangle, snap it from the origin. This is 667 17. It should be 1760, 1770, 1770 by 670, sorry. And also go to sheet metal, base flange. Also, the thickness of this is 1.2mm, and there's an edge flange of 30 or 40. Don't make it very big. You remember, you're not supposed to waste materials. Current economy doesn't allow you to joke around with the money. Okay, so 30 is ideal. You save on materials as much as you can, but 30 is very ideal. Actually, we normally do the 30. Even when the economy was good, we used to do 30 millimeter. That edge flange there is 15 millimeter. These are like standard things that we have been practicing for years, and even now that things have become difficult, we are not going to pass substandard equipment into the market. Go ahead and save it as part number 4, HC. And so you said shave is written like that or like this? What is the difference? I will go check later, but for now, you know what we are talking about. Go back to the assembly, insert component, insert undershelf. Now in the undershelf, yes, it should be like that, right? Right, should be like that. Met the top part of the undershelf to the bottom part of the side panel, and now you can pull the planes. This is the top, the right plane of the top meets with the right plane of the undershelf, like that. And also the front plane of the undershelf meets with the front plane of the top. Not really. I did choose front plane of the of the back panel, whereas it should be the front plane of the top. Yes, like that. Are we in agreement? Yes. Now, like I was saying, where is this back panel? Why is the back panel? The back panel is a bit short. Why? Something is not right here. What is the size of the back panel? It should be 1670. 16, not 16, but 17. 17, sorry. Don't know why I am talking about 16. It should be 17. This is why I told you working with SolidWorks is always fun, because if you've realized that you have done something which is wrong, you can go pull the sketch and edit it. Right, this looks right. I was wondering why was this clashing with the other one. Now see the room for your cables, the electrical part and all that, and how are you going to do the welding? Your welding should be at the edges, right? Edges. Okay, you don't want any welding to be seen. Now we are good. Let us do the side cover panel, and this we are going to evaluate, measure between here and here. That is 565. Normal distance is 565, and from here to here 660. So we got file, new part, okay. We go to which panel? Right plane, new sketch, center rectangle, snap it the origin. The length is 565. we can go with 5 6 watt 565, give it an allowance 563, and this is 660 658, give it an allowance of 2 mm. Yes. And also this panel, the cover panel, you can do it, sorry, I didn't mean to extrude, but go to sheet metal base flange. The side panel can be 1 mm or 1.2, depends with what you are having. And this has edge flanges going all around in one direction. Edge flange. Remember, our edge flange on the side panel is 25, so this you can make it 24. That's okay. Then 15 mm edge flange. Give it strength. Increases the mechanical strength. Very important. Like that. This is 15 mm. Right click and save it as part number 5. HC side cover. I hope you have followed the bent-in profiles and all that, because that is the most important thing, especially with the side panel and the back panel. Now, when we go to assembly and do the mating, you will see how the cover is mated. Okay. Now. This part met. This part sits on top of the undershelf like that, and this part flashes with this part, that face. Okay, now we can do what? Let us go to advanced mate and we go for width, because we want it sitting between this face and this face, and this and this. Beautiful. Now see, the hot cabinet is taking shape. This panel is the one that I was telling you is supposed to be removable. So you punch 4 holes and do your self-tapping screws or any other ball fastening fasteners that you can use. You need this to be removable, because at that space, that is where you're going to have all your electrical wires, cabling, contactors, and what have you in there. Now, with that done, we can mirror components, and we are going to mirror them. We can mirror them. This is the back panel, and we go for the right plane of the back panel, then mirror them against that plane. We want to mirror this and mirror this. Correct. Look, here there will be nothing in the sense that no electrical connections and all that. So what you can do, you do your tack weld here, you tack weld it here, you tack weld it here, you tack weld here. That becomes permanent. The aspect of cleaning, look, no hidden corner. No, this commercial kitchen equipment, and you don't want, we said cleanliness in the kitchen is of great importance. You don't want to contaminate any food. You don't want your customers having issues with their stomach because they ate some food which had some bacteria, virus, or what have you. So when you are wiping your hot cupboard, no hidden corner. You see, if the panel, let me show you something. no, there is no point. If the side panel had the profile going to the inside, like the way some people do. Some people do the panel going, this edge going to the inside so that they may avoid this cover going to the inside and all that. You will have an a dead corner here which you cannot always clean, right? So it's recommended you take it from the outside, and it is better you incur some expenses in having to use a sheet for this cover panel and the other panel, and make sure that you are given something which is absolutely beautiful. Now let us evaluate this so that we may get the size of the mid shelf. From there to there should be 1565, and from here to here is 670. That 670 you will subtract space for the doors. Okay, so we go to part, new part, top panel, you go to center rectangle as usual, snap it on the origin. This is 1560, I think. Give it allowance, 2 millimeter allowance, 1 millimeter on this side, and this is 6. We have seen it is 660. Is it 660 or 670? Should be 670. Then 670 we subtract 15 millimeter, the edge flange at the back, and door 30, that should be 60. Yeah, subtract 60. We are going to do what? Should there be need of editing it when we are fixing the doors? We will see. Sheet metal base flange, the undershelf also should be of 1.2 millimeter. That's good. You have edge flanges going this direction on these 3 sides, this side, and this side, and also should be 30 millimeter. Good. That's okay. You need to have an upstand here, say also 30 millimeter. Actually I should have done them together. Then here you have your edge flange 15 millimeter and edge flange at the back 10 mil. 10 or 15, no worry. Like I said, this will be determined by your benting tool, benting machine, and the benting tool you are using. If you have a benting tool which can do 8 millimeter, good. If you have an edge flange, if you have a tool which can do 15, the minimum that you can do. This is 15, and the mid shelf is good. Yes, the mid shelf. Why are we doing an upstand here? Again, cleanliness, cleaning this thing. You don't want the chefs having issues at any given time in doing their cleaning. I'm saving it as HC mid shelf. Good. Go back to the assembly and insert component, and the component we are inserting is mid shelf. Now met this part meets with the back panel. Then I think from there we pull the necessary planes What plane? Not that plane. Yes, that right plane of the top and the right plane of the mid shelf. You want it completely at the center. Where is it? Right plane. Yes. And you can go for the top plane of the shelf to the top plane of the top plane of the mid, the side panel. Yes, there you are. I hope we have enough room for the doors. So let us evaluate to see between this and this what is the normal distance. Around 50 millimeter. The door is 2020. You need to have 10 millimeters some players. We'll see when we start doing the doors. Now we will need to do channels for the legs. Let us evaluate and see between this and this. What do you have? 6. Normal distance is 6, right around 640. So we go to part. Let me first of all close these parts. I don't think I will. If I need them, I will pull them back, but for now we don't need them. Actually, only thing we need here is the assembly part. This we close. Yes. Top we close, and also this we close. You can save it and all that. Now we go to file, new part, click OK. Top plane, center rectangle. I believe even for beginners of SolidWorks, if you keep following 660 minus 30, 630, so we do 628. If you follow my tutorials, they might be for solid, for sheet metal, but you will become an expert in sheet metal, and when you're doing the other parts, the other modeling, you won't have any issue. This make it 1.5 because it will be carrying the weight of the cabinet. Okay, what am I saying? Surely the edge flange goes to the top, and this make it 28 or 30 there, because it should flush ideally with the undershelf. And this 15 millimeter, we shouldn't have mirrored the side panel. At least we should have waited for everything. And this is part number 7. HC leg bracket, leg channel. We go back to the assembly and insert the channel. Simply insert component, this channel, we rotate it. That's nice. How are we mating it? Met. This flashes with this. That's right. And this part to this. We are going to change something there. then you can do width. Like I keep telling you, there are so many ways of doing your mating. You can mate that part to this part, or you can go for the planes, or you can go for width. Yes. I think we gave our channel, the dimension is not very good. Let us evaluate and see. This should be 6 watt. From between this and this, 640. Normal distance there is 640. So we edit the sketch and make it 640. 640. And also we edit this bend, this edge flange, we edit it from 28 to, let's see, 26. Yeah, you don't want it to protrude, eh? Let's see, save the changes. Let's see whether it looks good. Yeah, it looks good. Well, 2mm, you need to give it some allowance. You don't want issues while you are inserting it in here. Okay, now this panel, you are going to weld it here and weld it here. Okay, that is where you are going to have your legs. Okay, now let us go to file, new, we do part, click OK, go to top plane, new sketch, circle, origin, the diameter of the leg should be dia 50, and it is hollow. You need to offset it by 1.5 in the reverse direction. Right click, feature, extrude. The clearance is 100. Remember, 710 plus 100, that should be 8. No, it shouldn't be 100. 710 minus 860, you have what? You have 140, and grommet is 30, so that is 110 on 110. Sorry. 110 is the height of your leg. Okay, now are we going to get it right? Save. Part number 8, leg. I should have done the HC part, which is still okay. Insert component, back to the assembly and insert component. To insert is leg. Now we met this face. You are going to weld it. I feel like this channel, we shouldn't have done it like that. Alright, yes, actually, let me delete this and this completely. Yes, then let me insert components, leg channel and the leg channel. No, I should have rotated the leg. Ah, man, what did I do? Move, rotate. I don't like this. We are rotating it on Y 90. Now this is, what is this? Why 90? Apply. Ah, no, yes. Yes, it's good. No, I need to rotate it again around what? Move component, rotate. Z 90. Apply. Okay. Component rotate this one. Where is it? Should it be Z or it's X? 0 X 90. No way. I mean, I keep telling you, me, I don't like rotate. I like rotating at the point of inserting channel. I rotate it on the y-axis and on the z-axis. Yes, like that. Always simple. This other rotating gives me all sorts of troubles. Now, mate. Again, we want this to flash with this. Right click. Then this touching that. Right click. And this touching this. Click OK. Yeah, not that. This is it. Which one? What's going on here? I think we are good, right? Yes, we are good. Yes. Now, yes, we are good. Now, let us take a look at this. Evaluate this first, that we may edit it. Measure from here to here. Should be 70, should be around, say 51. So we need to subtract by 20, 19. Edit the sketch and subtract this with 19, minus 19. Minus 19. Yes. You know, the idea is to have the leg being fitting correctly here so that you may do your welding in between that, okay? Sure. Go back to the assembly and do the insert component to insert here is leg, and do your mating. Now this leg, we are going to edit it and increase its height by 30 millimeter. Remember, it is that part is touching. It's touching which part? Is touching this part. Okay, and you want to do tangent. This should be a tangent of this edge. Click OK, and this should be a tangent of this edge. Which edge is this? This edge. Which one is it again? This let's see the positioning of the leg. Yeah, so that you do your welding should be here, here, and here. That welding will be strong enough to carry the cabinet. So let us increase the height of the leg by 30 millimeter. Remember, initially we had done it at 110 because we were welding it on top of the channel. So 30 millimeter has gone into the inside. Yes, save. That's good. Now we go to new part. We do the door part. What is the size of the door? We will find out. How is the profile of the door? Center rectangle. We shall find out. No. Shall we go back to the assembly and do some measurements? Yes. Evaluate. This should be 16 something, 1565. 1565 divide by 2. 1565 divide by 2, 782 plus 20 plus 28. Let's do 805. 805, and here we still get the 805 up to here, right around 660. (805) minus 30 is the length. 805 minus 30. You will see why we are subtracting 30, and this is 660. 660. We need to, that is okay, 660 or 655. We shall see. We shall see when we are doing our mating. Go to sheet metal, base flange. The door should be 1.2 millimeter. Don't put a heavy door there. Right, now we do need an edge flange of 20 millimeter. 20. Also this should be 20, the same direction. That's good. Now the 30 that you saw me subtract should be right around here, edge flange. 30. Yeah, 30. That's okay. To create the pocket where you should insert your fingers so that you may slide your door up to vertex, and the vertex is this one. Right click, then you do a double fold and 10 millimeter. There. You don't want any sharp edge. Here is where you insert your fingers and slide your door. Now that is that, we need to have an edge flange round here of, is it 20 millimeter? Yes, 20 and 20. That edge flange should be 20 millimeter. Right click, hope, yes. Then we have edge flange of 10, 15 millimeter in these three edges. 15. Right. Now that is our door, our sliding door. Our sliding door. Save. Let's part number 9. Let's see. Sliding door. Okay. Let me start an assembly of the sliding doors. Here you will need to weld your rollers on this side and on the top, this side and this side, right? So I don't think it is very necessary for me to draw that roller. I will just pull it and show you how it will be like a new assembly. Okay, and here I need my sliding door, and I insert component. Let me browse, go to projects, tutorial, Artcardboard. I had done this. Where is the sliding wheel assembly? This, sorry, that is what I want to open. Yes, there you are. Now look, this is just a roller with a pin. It can slide. Okay, a roller with a pin and a bracket, and this bracket is the one that you're going to weld it as shown. This to this. What's going on here? Are we not supposed to make that face and this face? And why is it rotating? And this edge to this edge, or we give it some distance. Then you need to have a distance of about, that roller is about 30 millimeter. Let me see, 35. We do trial and error between this and this top. 35 is way too big, so we can do 20. Just need like 2 millimeter. 25. Yes, there you go. There you go with your roller. We need 2 of them, so I don't want to mirror that. Let me linear component. First of all, let me evaluate measure from here to this edge is what? 776. So let me linear component 776. It might not be very accurate, but we are going to play around with it. Which direction? The second direction. Why don't you change your direction? It's like that. 2 of them, and the component is this. That is the component. Yeah, 776 minus, I think this should be 25. Minus 25. Is it flashing? Almost flashing. We do 750. Right. So there you go. You have your door, your sliding door. Save it as this is the right side. Right? No. We save it from our layout auto cabinet HC, and we'll call it right. We are saving it as right. Oh, right sliding door assembly. Now we will start another assembly here. File, new assembly, click OK. Yes, then we bring in the sliding door and rotate it on the Z axis. Yes, and we will bring again assembly, insert component to insert here. Let us browse again and bring that that sliding wheel. Yes, like that. Then we do our mating just like we did with the first one. That part to that part. Okay, this edge, last time we mated it with which edge? With this edge. This edge. Click OK. Then we did some distance of, was it 25 millimeter between this and the top. Like I said, we will see and do the necessary adjustment. Linear component, that's the direction. Reverse the direction to components and components to linear. Yes. So go ahead and save this as project SolidWorks layout HC left side left sliding door. Good. Okay, now we go back to the assembly. Before we do the we insert the doors. We will want to evaluate and see the distance here because of the channels, the sliding channels. We want to measure that face to this face is 1565. Okay, 1565. We got file new, but click OK. Front plane sketch, and this center rectangle, the length should be 16, 15, 64 or 63, and the height should be 50. That's okay. And we go to sheet metal base flange. 1.2 channel is okay. Now look at the profile. This should be right around 30. That edge flange and edge flange here. 30. Is it 30 or 25? I think 30. We shall see. Then we have edge flange, which will have like the stopper of the wheel. Going to that side, 15mm. You can have for strength another edge flange there. That's good, yeah. And we call this, we save it, not save us. What did we save us? Layout HC part number 10, and we call it sliding HC, sorry, HC sliding channel. Good. Now there is a trick someplace. Let me first close this. I close this and I close this, and I be left save all. I be left with the doors and the sliding channel. There is a trick someplace. Okay. Let's see. I'm thinking. Let me insert component first. Insert component, and I need to bring in the sliding channel. Okay. Met the top part should be to that part, and this face should touch the edge of the top. Will I ever get that edge? Surely. Yes, that should flash with this. Then I can go to and pull the top and go for the right plane. Then I go for the sliding channel and go for the right plane of the sliding channel. That's good. Yes. Yes, that's good. Now, can we first hide the top? Yes. Right. This channel you are supposed to do welding here and just small welding here. By the way, when you are doing the assembly of the cabinets, the top is the one that you normally weld the last. Okay, because as you insert this channel right here, you need to do the doors so that you may make sure that they are running smoothly. Let us start with the right sliding door. How are we going to? Right. Now, that being the case, I hope I'm doing the right thing. Let me met. Just bear with me once. Okay, let us do advanced met, and we go for the width. That is this and this. Should be in between the channel. That face and I see that face surely, and let me just go for that. Yes, and that. That's okay. And this, the bottom part, should be touching the top part of the shelf, the under shelf. What's going on here? Clear. Let me clear that first. This is the bottom, and that something is not right. No, should go for coincidence. Standard mate coincidence. Coincident relationship. That and that. Okay. Now let us see the orientation of the wheel. Yes. I will change something here. Let me go for the mates and edit this width. Edit. And instead of doing width, let me clear all this and this. I clear. And instead of doing width, I do standard mate, and I go for distance, and that distance should be some 2 millimeter, 2 or 1 millimeter, 2 millimeter between this face and this face. Exactly. Wait to see whether our sliding wheel it should be on the reverse side. Just bear with me. Edit. Is it flip dimension? Yes, like that. You want there to be clearance, but again you need to be very careful. You gave it 2 millimeter, so it shouldn't be 2 millimeter. Distance. Edit. Even when you are doing the real assembly, this is always the most challenging part of the cabinet, to get it right, to get the channel and the wheel right. Point 5. Did we flip dimension? No. We shall see. In fact, very few fitters normally get this thing right. Well, still the wheel is touching the channel. distance, edit, let us edit this, and instead of doing distance clear, we do coincident relationship. Let me see. This face, not that face. Clear this, delete this. It is that face, and just bear with me, guys. Not that face. I want this face. I want this face. What happened? No, it flipped. Wow. Let me delete the whole thing. Yes. Let me bring it again. Me insert component again. Just bear with me, people. Left, right, sliding door. Okay. Now we need this met this face to met with this face. Where is the face? That face. Okay, you don't. Well, the wheel is inside. I just wanted. Well, when you are inserting, you just make sure there is at least a small gap so that there may be no friction between that bracket and the sliding channel. That is the idea. That's okay. This seems to be okay now. Let me see. Yeah, it seems to be okay. Your door can slide between that channel correctly. Okay. Yes, it can slide, and it is almost flushing with the outer part. Now I want to do a small thing, a very small bracket that holds these two doors from the lower part together, so that this door may not. Let me do it. I will explain it. So I will go to the top panel, new, and go for center rectangle. Just a small. This should be like even 20 mil or 15, and the length should be, the door is 25. It's like a U channel. 25. Let me do 26 mil. That's okay. No, 30. Yes, 25, 25, 20, 25, 26, 28, 27. You're wondering what's up? 27. Yes, 20 by 27. That's good. Smart dimension. That is good. Sheet metal base. Just a small U channel. 1.2 is good. Then we have an edge flange here of, say, mm, 15 or 18 millimeter, 18 mil. Yes, no, let's do it 20. That's okay. Then we have edge flange here of around 12 millimeter. That's okay. And finally we have an edge flange here of here is the trick of say 10. Here is the trick, my friends. This holds your doors together. Let us call it part number 11. HC holding bracket. Okay, now we go back to our assembly and insert that component, that small component, that holding bracket component. That's what we are going to insert, and we are going to mate it like this. This part, that face to that face, and we pull the not sliding panel. Let's go for the not top but under shelf, mid shelf. Then we go for the right plane, and that small part holding bracket right plane. Yes, exactly. Then with that done, we take this I want this face. Will I ever see that face? Surely. Yeah. Let me pull it from the outside. This face and the face on the inside of the sliding door. No, let me first clear this and make the door. Surely. Can I make this transparent? Transparent. I changed the transparency so that even this, let me change the transparency of this. Yes, exactly. Now let us make components, and I wanted clear. I wanted to, what's not happening? Yes. I want to pick this, that face. To which face? Oh la la. I want to choose this face, not this face, this face. Well, maybe something like that. Okay, let me do this. Let me change this transparency. Collapse this. And then collapse which one? Collapse the back panel. Mid shelf, mid shelf, mid shelf. Yes. So that very small bracket that you have seen us inserted there, we are going to edit where necessary, but it holds this door. You see, at least the second door, let us insert. Let me finish with all this, then I will explain what we are talking about. Insert the left sliding door, yes, and here the first mat will be this face and this face. That's good. Then we can go for advanced mat, and we do with this, and this should be inside that small bracket, should be between this and that face. That's good. Now let us slide it and see. Now, when the door is locked, when this door is locked, we will need to edit. Let me see the gap. The gap. 10 millimeter. Is long, it's big, it's huge. We can do this 2 millimeter. Open this edge flange, we edit this. Can your machine do a bent-in of 6 millimeter? 6 mil. This is a small bracket. You can find a way of doing it. It is very important. You can't do without it. I'm telling you, honestly, you can't do without that. Yes, the gap is ideal now. 6 millimeter is not a big gap. It is very ideal. Now this we need to edit. Just 1 second. Evaluate. Measure from here to here where we have the edge flange. It should be 610. So we open our mid shelf and edit that sketch. Edit this sketch. 610. 595. Oh, plus 15. 595 plus 15. That should be 620. So here we are supposed to subtract like 12 millimeter minus 12 mil. That's good. Oh, we want there to be some clearance between the door, the sliding door, and the shelf. Okay, just follow the drawing and you will be good. Yes, see, it is not touching the door. It is not touching the rear door. Now. Let us again insert another channel, sliding channel. Sliding channel. There. And this makes how? Exactly. Met. The first met will be between this, that inside. Is it the inside? No. The outside. Clear. The outside and the inside of this wheel. That's good. And this should be the same height as this. That's good. And what else? That edge, we can go for the front. This is front of what? Mid shelf? Not front, but clear. Right plane of the mid shelf and right plane of that sliding channel. Yes. That's good. Perfect. Now you see, let us hide this. No. Should have hidden it. Let me hide it. Exactly. Now you see, this bracket, the door cannot move. Okay, one second. Yeah. Your channels, they are colliding. You will need to do some adjustment to the channel. We made it 50, you can do it. Let us do it. I'm telling you, this is the most difficult part. 30. We can do 28. The most difficult part in all the fabrication that I've been doing commercial kitchen is doing a sliding door cabinet. A cabinet with sliding doors, and it is sliding from the top. Always has a lot of issues. Still, why don't we expand this a little bit? In fact, that 10mm that we were, this edge flange, we gave it 6. Let us do it 10mm. Yes, your channels are not, you don't want there to be a big gap between the doors. This gap, though there is no harm. Yeah. Okay, so you see that this channel, this small bracket, at no point will it ever be seen by anybody. In fact, very few people normally know whether it exists, because if you open this door to the max, it still remains hidden there. Okay. If you slide this door and close it completely, and you also close the other one completely, that small channel is nowhere to be seen. And this prevents, it is very very important. If you don't get that right, then you will have issues. Remember the hook that is going downwards, where is it? Yeah, this hook is holding the door such that it cannot go to the front, because there is no stopper here at the front. So that door is held in place, it cannot go this side. Okay, and the one the U part is holding this other door. Remember this, you're going to tack weld it on the undershelf. It is holding this door, it cannot what do we call it? There is no, is this horizontal? Yeah, there is no horizontal movement at the lower side. At the top side you have no issue, because the channel, this which is welded to the door, and the wheel is being held by this, it can't go anywhere. There will be no movement, there will be no horizontal movement on the doors, so the doors will be in place. So the recommendation is, first you do what? You do the side panels and the undershelf and the back panel, and now fix these channels, the sliding, and also the mid shelf. You can do the mid shelf if you want, and deal with the doors, because once you put the top, it will be very difficult to do these channels, and also it will be very difficult to set your doors well. It should be very parallel. Any slight deviation from the parallelism, the doors won't be sliding smoothly. So do that first, and you will have very little problems with your cabinet. Otherwise, you can do your assembly. In the fabrication, you can do your assembly, and you find that your cabinet, the part that slides, ain't working. What is wrong with this? Okay, the overshelf, with overshelf. Where is the mid shelf? Mid shelf. Make it visible. Right. So I think now the remaining part is to go for the top part, and go for the front, then mirror components, and component to mirror is the leg. That's good. Then go for the right mirror component, and the components to mirror is this leg and this leg, and right click, and your cabinet is good. Right, I hope you have gotten the key points. Here is the sliding part of the door and this panel. Now the other part is the electrical part. Remember again, when you are doing your DXF, you need to punch holes for the control of the control probe. The electrical part, you need 2 holes. You need a hole for this probe, for this knob, and for the indicator. Okay, and that will be it. The others, a matter of drilling holes for the sliding. For you drill holes for the removable part, put in some screws, self-tapping screws, and also you'll need some holes here. You weld the nut or the bolt on top of the top for the overshelf. We will do overshelf in our next video. This video has taken a lot of time. We will do overshelf in our next video. Thanks so much for your time, guys. See you in our next video.